So last episode of CMA 8th Grade Math Academy, Mr. Grady brought it with some really strong dad jokes. So, being a pretty competitive guy, I'm like, well, I got to bring it right back. So here's Mr. Schrog's editions of dad jokes. So first one here, want to hear a joke about a piece of paper? You know what? Never mind. It's terrible. I'll just let that one soak in. Yeah, that's pretty great. Okay, well, tough to come back from that, but we're going to go ahead and just jump right into the math. So here's our learning goals for the day. So here's the what. Well, by the end of today, you're going to be able to estimate cube roots to the nearest tenth, which sounds pretty familiar, and that leads into our why, because we have estimated square roots, and now we are going to be solving for cube roots. How will you know when you've been successful? When given a cube root, students will be able to estimate the answer to the nearest tenth. So very similar here to our square roots lesson, except now we're working with cube roots, which is 3 instead of 2. And so a lot of this is going to seem like deja vu. It's going to be very similar to Mr. Grady's video from earlier this week. But everything is kind of similar, just a little bit different process here for cube roots. So let's dive in. If you don't already have a paper, I'm going to give you guys a second to get one. Your teacher will come by and pass it out. When you see it, you're probably going to think, oh, I already have this. No, you have the square roots one. This is the cube roots one. So before we dive into this paper, though, I want to kind of talk about what cube root means and what a cube really means. So if you imagine a cube, or look at the one up here on the screen, you've got a cube has 3 side lengths that are all the same. And we know to find volume, we take the side times side times side. That gives us the volume of the cube. So we can say that the side cubed equals volume. And if that's the case, then the cube root of volume, which just looks like a square root, but it has a 3 right here, that is going to give us the answer to one side, because one side equals the cube root of the volume. So if we have this cube right over here and we know the volume, let's say the volume is 64. Well, if the volume is 64, then if we can find the cube root, or in other words, the number that multiplies by itself 3 times to equal 64, then we'll know the side length. And in this case, that side length is 4. Okay? So anytime you get stuck today, or you forget what a cube root is, or what cubing something is, just think about an actual cube, visualize the cube, and remember that volume is kind of like cubing the sides, and finding one side is like cube rooting the volume. So hopefully that helps. Now let's go jump back into our notes. So at the top it says a perfect cube root is when the answer to a blank is a blank. You can probably guess what's going in those blanks. It is cube root and whole number. So just like with perfect squares, a perfect cube root is when our answer is a whole number. We don't have any fractions or decimals to deal with. Okay? And then down below, you're going to see lines very similar to when we did perfect squares, except now you have a third number that you're multiplying. But it follows the same pattern. So we're going to go 1 times 1 times 1. Well, that still just equals 1. When we get to 2, it changes because we have 2 times 2 times 2. Well, 2 times 2 is 4, and then 4 times 2 is 8. So the cube of 2 is 8. Now what I want you to do is fill in the rest. So you're going to go from 1, just like we did with squares, except all the way to 12 times 12 times 12. Okay? These numbers are going to be quite a bit larger than our square numbers were. Okay, I'm going to give you some time now to try to fill in as many as you can. Go. All right, so hopefully you've had a chance to fill in those or at least get a good start on those. I'm going to go ahead and throw up the answers just so you guys can check and make sure that you got them. So 3 cubed is going to equal 27. 4 cubed is going to give us 64, which also happens to be a perfect square because 8 times 8 gives us 64 as well. And then we have 5. The cube of 5 is 125. So 125 is a perfect cube root, or a perfect cube. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. 10 cubed, we should know this. 10 times 10 times 10 is 1,000. 11 cubed is 1,331. And finally, 12 cubed is 1,728. Okay? So, just like with the squares, this paper is going to come in very handy when we're solving. So make sure you have this in a safe place. Keep it in your binder. Do whatever you got to do to make sure you don't lose track of this paper. All right. So similarly to the fill in the blanks for the steps to solving cube roots, they're very similar. So I'm going to give you just a second here to fill in these blanks. You're going to find that they are very similar to the steps for estimating square roots. All right, so our first step here that we got to do is finding the perfect cubes that come before and after 50. So we need to find the one that comes before 50 and the one that comes after 50. And remember, there's going to be a 3 now there instead of just the square root sign. It's just like the square root sign, but we have 3's there. Okay? So then if you go back up to your list, you can tell that we're going to have 27 and 64 are going to be the perfect cubes before and after. So let's go ahead and fill those in. So 27 and 64. Okay. Now step 2 is find the cube root of each of the perfect cube. Well, 27, its cube root is 3 because 3 times 3 times 3 equals 27. And the cube root of 64 is 4 because 4 times 4 times 4 equals 64. Okay? So we're done with steps 1 and 2. Now we get to step 3, which is determine which cube root your answer should be closer to. Well, 50 is kind of in the middle of 27 and 64. It's a little bit closer to 64, so I'm going to assume it's going to be on the high side of our halfway point. And so I'm kind of expecting it to fall in this area down here. Okay? Step 4 is calculate the cube of the halfway point. So right between 3 and 4. Well, we know this is going to be 3.5. So we have that there. And now we need to find out what 3.5 cubed really is to give us another point to use when we make our estimation. So this is going to be a little more challenging maybe than when we squared it, because now we're going to have to take 3.5 times 3.5, find our answer, and then multiply that answer times 3.5 to really get to 3.5 times 3.5 times 3.5. So I'm going to go over here. I'm going to switch to a different color. So I'm going to start by doing 3.5 times 3.5. And when I take 5 times 5 and 5 times 3, I'm going to end up with 5 times 5 is 25. Carry my 2. 5 times 3 is 15, plus 2 is 17, so I end up with 175. Then I add my 0, my placeholder, don't forget to do that, and then I take 3 times 5, which is 15, carry my 1. 3 times 3 is 9, plus 1 is 10, so then I have 1050, and now I make my addition problem. 5 plus 0 is 5, 7 plus 5 is 12, carry my 1. 1 plus 1 is 2, and 1 plus 0 is 1. So then I have 1,225, but we know if we have 2 decimals in the numbers that we're multiplying, then we need to move 2 places in our answer, so it's really 12 and 25 hundredths, and then I need to take that times 3.3 and 5 tenths again. So this time again, we start out with 5 times 5, which is 25. 5 times 2 is 10, plus 2 is 12. Carry my 1. 5 times 2 is 10, plus 1 this time is 11. 5 times 5 is 1, plus 1 is 6. Again, placeholder, don't forget that placeholder, 0. 3 times 5 is 15. Carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 2 is 6, and 3 times 1 is 3. And I make this an addition problem. 5 plus 0 is 5, 2 plus 5 is 7, 7 plus 1 is 8, 6 plus 6 is 2, carry the 1 is 3 plus 1 is 4. Okay, and we had 3 decimals that time, so this is going to give us 40 decimal there. So I have 42 and 875 thousandths. So now we definitely know that our answer needs to be larger than 3.5, but less than 4, somewhere in the middle there. And so now is where we're going to make our estimation. Well, 50 is a little bit closer to 42 than it is 64, so I'm going to go with 3 7/10 to start out with the check. So over here to the left this time is where I'm going to go, and I'm going to switch colors again to an orange-green color. I'll go with green. And we're going to take 3 7/10 times 3 7/10 to start with, and then we'll multiply that answer times 3 7/10 again. So we have 7 times 7 is 49. Carry the 4. 7 times 3 is 21. Plus 4 is 25. So I have 25. So I have 259. Again, placeholder 0. Move on to the 3. 3 times 7 is 21. Carry the 2. 3 times 3 is 9. Plus 2 is 11. Make this an addition problem. 9 plus 0 is 9. 5 plus 1 is 6. 2 plus 1 is 3. And 1. Okay. Again, 2 decimal places, so I really have 13 and 69 hundredths. And now, once again, we need to turn this into a multiplication by 3 7/10 because right now I've only squared it and I need to cube it. So 7 times 9 is 63. Carry the 6. 7 times 6 plus 6 is 48. Carry the 4. 7 times 3 is 21, plus 4 is 25. Carry the 2. 7 times 1 is 7, plus 2 is 9. And then I've got to, again, make sure I have that placeholder of a 0 there. And then take 3 times 9, which is 27. Carry the 2. 3 times 6 is 18. Plus 2 is 20. Carry the 2. 3 times 3 is 9, plus 2 is 11, carry the 1. 3 times 1 is 3, plus 1 is 4. And now I do my addition. 3 plus 0 is 3. 8 plus 7 is 15. Carry the 1. 1 plus 5 is 6. 9 plus 1 is 0. Carry the 1. And we have 50. So now I need to move my decimal 3 places. So I have 50 and 653 thousandths, which is very close to 50. So we know, okay, we made a good choice in estimating that it was 3 and 7/10. So I write 3 and 7/10 and circle it because I'm proud of my answer. So steps are very similar as they were with square roots, but now we're just cube roots. And so now we're going to do 1 at the bottom, and then you are going to solve 1 by yourself. So let's go down to the bottom where it says the cube root of 100. So we're going to do the 100, and then you're going to find the cube root of 30 here in a second. So let's start out by finding the perfect squares that are before and after 100. Well, if you look at your list, 64 comes before 100 and 125 comes after. So those are going to be our cube roots that we use. Again, remember to draw that 3. That 3 is important when you're drawing the root sign. We've got 125 is larger than 100 and 64 is smaller. And then step 2 is to find the cube root. Well, the cube root of 64 is 4. Cube root of 125 is 5. And now we need to find our middle point. Okay. All right. Well, just for the sake of time, for the middle point of 4.5, when we multiply 4.5 times 4.5 times 4.5, our answer is going to be 91 and 125 thousandths. Okay, so that's our halfway point. So if we know our halfway point is less than the number that we're after, right? Our target is 100 up here. We know we need to be on the right side of 4.5, but still less than 5. So I'm going to draw my arrow. We're going to be in this area around here. Okay. All right. So now your job is to determine if our best answer here is 4 6/10 or 4 7/10. Okay. So what I want you to do is in your table or your group, one person is responsible for finding the cube of 4 6/10. Another person is in charge of finding the cube of 4 7/10. And then we're going to decide which is a better answer, which is the best answer for estimating the cube root of 100. Okay? So again, one person is going to find the cube of 4 6/10. The other is going to find the cube root of 4 7/10, and we're going to compare. Okay? So I'm going to give you some time to do that now. Ready, go. All right, so hopefully you've had time to find your answers, and hopefully you and your partner came up with this as your answer. So 4 6/10 cubed gives you 97 and 336 thousandths. Okay, and 4 7/10 squared gives you 103 and 823 thousandths. Okay. So now our job is to determine which one of those is closer, because it seems like 100 is right in between. But if you think about it, 100 is actually a little bit closer to 4 6/10, because 4 6/10 gives us 97 and a little bit more. Okay, so it's a little bit closer than 3. But the other one, 4 7/10, gives us 103 and then some extra stuff. So it's really a little bit over 3 away. So in this case, 100 is just a little bit closer to the cube of 4 6/10. So 4 6/10 is our answer. That's what we're going to circle. Okay. And now we're done. Okay. So again, just to recap, very similar to cube roots, or sorry, square roots, except we're just using our cube numbers, our perfect cubes, and anytime we estimate and check an answer, we multiply it by itself 3 times instead of 2. Okay? So now your job is to solve the cube root of 30, check with a partner, make sure you get that one right, and then you can go on to the back, which is your homework. If you don't get it done, you should have time here in class to get this done. So you've got 3 cube roots to estimate on the back, and then you have another word problem to determine if somebody made the best estimate possible. Okay? All right. You may begin.